Einstein didn't sit at Princeton dreaming this up in 1905. In 1905, he was a patent clerk in Switzerland, dropping special relativity. By 1915 in Berlin, he finished general relativity. He only moved to Princeton's Institute for Advanced Study in the 1930s. Here's the idea that changed everything. Space and time aren't a stage where stuff happens. They're the stage and the script. Mass and energy tell space-time how to curve. Curved space-time tells matter how to move. People love the bend space to shortcut distances. Bit. Think of a sheet of paper with two dots. Fold the sheet. Those dots touch. That's the wormhole idea. Could it work? Maybe in equations, but it would need exotic matter with negative energy to hold it open. We've never made that in the lab, and the energy requirements are ridiculous. About speed, the universe has a speed limit, light speed. If you have mass, you can't hit it. As you accelerate closer, time for you slows compared to people who stayed home. That's time travel to the future, and it's real. GPS literally corrects for it every day. Backwards in time, that's where physics gets slippery. General relativity allows weird loops called closed time-like curves in extreme scenarios, rotating universes, certain wormholes, but we don't have a way to build one, and quantum effects might kill the party. The twin paradox: one twin rockets near light speed, turns around and comes back. The traveling twin has aged less, not hours versus 80 years. That's movie math. The actual difference depends on speed and path. Push near light speed long enough, and you can skip far into Earth's future while you only age months or years. Einstein first preferred a static universe, adding a cosmological constant. Then observation showed space is expanding. He called the constant a blunder, though today we use a version of it to describe dark energy. Geodesics are the straightest possible paths in curved space-time. Planets don't mesh like gears, they surf those curves. That's why orbits precess, light bends, and time runs differently on mountaintops. In short, bendy space, stretchy time, and a limit that lets you leap forward, just not backward, into tomorrow. And it all started with a clerk who looked at the clock and changed how we measure it. What if everything you think you know about how spaceships move is completely wrong? Here's a mind-bending thought experiment. Space isn't just mostly empty. It's a complete void. Its energy ratio measures 0. Think about this. A ship in space becomes truly weightless in this environment. No weight, no cause for resistance. This changes everything about propulsion. In this void, propulsion becomes instantaneous upon departure, with absolutely no space drag to slow you down. Here's where it gets really wild. Everything interacts directly, void of momentum, even during acceleration and advance. The normal rules we're used to simply don't apply. So next time you watch a space movie, remember, the reality of space physics might be far stranger than fiction.